Hi everyone and welcome to lesson 3 on topic of Fizz and Pop for year 7. To complete this lesson you'll need a pen and some paper, so if you do not have them in front of you please pause this video and go and find them now. Today's lesson is on making a salt, and the challenge for this lesson is to know how to make a salt, and the aspire is to explain how salts can be made using evaporation. So the start of this lesson is a quick 6 recap challenge, and this is recapping what you have learnt so far in the Fizz and Pop topic. So question number 1, what pH is an acid between? Question number 2, what pH is an alkali between? Question number 3, what pH is neutral? Question number 4, what indicator tells us the pH of a substance? Question number 5, if used an indicator, a substance is orange. So is it acid, alkali or neutral? And question number 6, if you use an indicator, a substance is blue. Is it acid, alkali or neutral? I'm going to give you 4 minutes to complete this task. Off you go. Okay, so let's go through the answers. So the question, what pH is an acid between? If you written anything between 0 and 6, then you would be correct. Question number 2, what pH is an alkali between? It is between 8 and 14. Question number 3, what pH is neutral? It is pH 7. Question number 4, what indicator tells us the pH of a substance? And that is universal indicator. And question 5, if using indicator a substance is orange, is it acid, alkali or neutral? The answer is it's an acid. Question number 6, if using indicator a substance is blue, is it acid, alkali or neutral? It is an alkali. So please add up your marks out of 6 and write down how many that you've got. Okay, so the first thing that I'd like to do with you is recap what we have already learnt so far in the topic of fizz and pop. So we've already looked at what happens when an acid reacts with an alkali, and sometimes we call an alkali a base. Now when an acid and an alkali react with each other, a neutralization reaction occurs, and salt and water are going to be the products of this reaction. Now salt and water are both neutral solutions. They have a pH of 7 and in universal indicator they would be green. So the reactants of this reaction is obviously the acid and the alkali together. And just a few bits about this. When you add an acid and an alkali together to get neutralization, you must add them in the same increments. So for example, if you have an acid that is pH 0, to neutralize it, you have to add an alkali to it of pH 14. And similarly, if you have an alkali that might be pH 3, for example, if you add an acid to it that is around about pH 11, then again you will get that neutral solution that will be green in universal indicator. Just a couple of reminders as well. Other examples of bases are metals, so that could be any metal such as iron, copper, zinc, magnesium, calcium, sodium, potassium. Metal oxides, so iron oxide, copper oxide, zinc oxide, calcium oxide, sodium oxide, and the metal carbonates, so such as magnesium carbonate, calcium carbonate, sodium carbonate, iron carbonate. So they're all examples of bases. So just a quick quiz now, just to have a little look to see what we've just remembered from what I've just said to you. So question number 1, what are the reactants in the reaction of neutralization? What are the products in the reaction of neutralization? What colour solution would you produce at the end of this reaction? And what pH would the solution have? So I'm going to give you 2 minutes to write down your answers. Off you go. So the answers that you should have, guys, so please get a pen so you can mark these. Question number 1, so the reactants of the neutralization reaction is the acid and the alkali. The products is the salt and the water. It would go green with the universal indicator, and the pH of the resulting solution would be pH 7. Okay guys, so now we're going to go through how to name salts. And this all depends on what acid you are using. So if we are using hydrochloric acid, we always make a chloride salt. If we are using sulfuric acid, we always make a sulfate salt. And if we are using nitric acid, we always make a nitrate salt. Now, the word chloride, sulfate and nitrate is always the second part of the salt's name. The first part of the salt's name always comes from the first word of the alkali. So you can see these examples below. We have hydrochloric acid. So we know the second part of the word of the salt will be chloride because we know hydrochloric acid makes a chloride salt. And the first word of the salt will come from the first word of the alkali, which is sodium. So hydrochloric acid plus sodium hydroxide will make sodium chloride plus water. The next one, if you have sulfuric acid, we know sulfuric acid will always make a sulfate salt. So the second word of the salt will be sulfate. The first word of the salt will be copper because that's the first word of the alkali, which is copper oxide. Actually, this is a base. Copper oxide is actually a base. So we have sulfuric acid plus copper oxide, and this gives copper sulfate plus water. And then the last one, nitric acid, that will give us a nitrate salt. So you can see nitrate is the second word of the salt of magnesium nitrate. And the first word of the salt is magnesium, and that comes from the first word of the base, which is magnesium oxide. So here we get nitric acid plus magnesium oxide gives us magnesium nitrate plus water. So what I would like you to do now is actually have a go at some of these yourself, and I'm going to give you 5 minutes to complete these word equations for these different reactions of acids. So the first one is hydrochloric acid plus copper oxide gives copper blank plus water. Nitric acid plus potassium hydroxide gives blank nitrate plus water. Sulfuric acid plus blank blank gives sodium sulfate plus water. Hydrochloric acid plus magnesium oxide gives blank blank plus water. Blank acid gives plus sodium oxide gives sodium sulfate plus water. And nitric acid plus iron oxide gives something nitrate plus blank. So I'm going to give you 5 minutes to complete this task. Off you go. Okay everyone, so you've had your time now, so let's go through the answers. Please get a pen so that you can mark them. So question number 1, hydrochloric acid, when it reacts with copper oxide, we get copper chloride. Remember, hydrochloric acid will make a chloride salt. And the word copper in copper chloride, the first bit of the word of the salt comes from the first word of the base, which is obviously copper oxide. So you get copper chloride and you get water. The second one, nitric acid, will make us a nitrate salt, and the first part of the word comes from the alkali, which is potassium hydroxide. So nitric acid plus potassium hydroxide gives potassium nitrate plus water. Question number 3, sulfuric acid, that will obviously give us a sulfate salt, and the first word of the base is aluminium, so we'll get aluminium sulfate plus water when we react sulfuric acid and aluminium oxide together. Question number 4 is hydrochloric acid and magnesium oxide. So we will obviously get a chloride salt there because we have hydrochloric acid and the first word of the base is magnesium, and obviously we get water as well. And then sulfuric acid plus sodium oxide will give them sodium sulfate plus water. And the last one, nitric acid plus iron oxide, will give us iron nitrate plus water. So already this year you have learnt how to make a salt. You did it in your last chemistry topic called shifting states. So I want you to think back to that topic and when you was making salts, and what methods did we use to make a salt. So I'm going to give you 2 minutes to write down your ideas. Off you go. So over the next few slides then we're going to go through and just recap how we make a salt. So please just keep your answer to the last task to one side for me. I just want to ask you another question in between. So we are going to react copper oxide with sulfuric acid. What colour solution do we expect to see? So you should have already done this when you did shifting states. So this is the reaction of copper oxide and sulfuric acid to make copper sulfate and water. So I'm going to give you 20 seconds to write down what colour you expect the solution to be. So hopefully you've all written down that the colour of copper sulfate solution is blue. So I'm now going to go through with you how to make a salt. So hopefully you've got some of these ideas written down. So we add copper oxide to the sulfuric acid and we stir it using a glass rod. We continue to add copper oxide until no more will dissolve, and you'll know at that point because the black copper oxide will just sit in the bottom of the beaker. So what we need then to do is to filter the copper sulfate solution to remove any excess copper oxide, and once it's been filtered you get this lovely blue solution that you see that just contains copper sulfate. Now what we need to then do is we need to obtain the copper sulfate crystals from the solution, and to do that obviously we need to evaporate the actual liquid part out of the beaker. So I'm just going to remind you about evaporation on the next slide. So just a little recap into evaporation. So remember, evaporation is the changing of a liquid into a gas, and evaporation is constantly happening around us without us knowing. If you think about when it's been raining and you've got a puddle on the road, eventually it disappears because the water in that puddle has evaporated, and it's evaporated due to the air temperature, and that's obviously been heated from the sun. So evaporation actually happens at a faster rate when the temperature is warmer outside and the air is moving quickly. So if there's a nice bit of wind or a bit of breeze happening, then evaporation will happen at a faster rate. So the last part, hopefully guys, that you have written down is that you get your Bunsen burner, your tripod and gauze on a heat-proof mat. You have your evaporating basin and you add your blue copper sulfate solution to it. And then you heat the solution gently until the crystals begin to form. And then obviously you get these beautiful blue copper sulfate crystals that you can see in the middle of the slide. So now there are 3 questions to complete. I'm going to give you a couple of minutes to answer me these questions, guys. So the first question is, how can we remove the excess copper oxide when we are making a salt? How can we obtain copper sulfate crystals from copper sulfate solution? And is copper sulfate an element or a compound? So I'm going to give you a couple of minutes, off you go. So the answers to the questions are, how can we remove excess copper oxide? We can filter it. How can we obtain copper sulfate crystals from copper sulfate solution? We can evaporate it. And is copper sulfate an element or a compound? It is a compound. So in this experiment that we have just done, there are obviously risks associated with it. Now, if you think about it, we're using a Bunsen burner, we're using acids. So all of the things that you can think about, I'd like you to write them down for me, and also think about how then we can reduce the risks, not forgetting also that we're using glassware. So I'm going to give you 3 minutes to write down what are the risks associated with the practical and how then you can reduce them. Off you go. So hopefully guys, these are some of the ideas that you've written down and how you could protect yourself. So some of the equipment will be hot because you're heating it. So obviously you could burn yourself. So you need to ensure that it is cool before you touch it. The Bunsen burner, again, you could burn yourself. So ensure that the Bunsen burner is on a safety flame when it's not heating the solution, and take care not to burn yourself. The copper sulfate solution may spit, so this could damage eyes and skin. You should always wear then your goggles when you're carrying out an experiment. And the sulfuric acid is corrosive and it could damage skin and clothes, so you need to make sure that you wear eye protection and gloves if available. Also, you are using glassware, so be careful with it. Make sure that you keep it well on a bench so that it doesn't fall off, unable to break, and then obviously it reduces the risk of you cutting yourself. So the summary for today's lesson is a pH between 0 and 6 is acidic, and 8 and 14 is an alkali, and 7 is neutral. When an acid reacts with a base, this is a neutralization reaction. Examples of bases are alkalis, metals, metal oxides, and metal carbonates. To make copper sulfate crystals, you will react copper oxide and sulfuric acid. You need to filter out any excess unreacted copper oxide. The blue copper sulfate solution should then be heated gently using a Bunsen burner, and blue copper sulfate crystals will form in an evaporating basin. I'm going to give you 5 minutes to copy down these summary notes. If you need any more time, then please pause the video and complete today's notes.